Good afternoon, students. You can your videos. All of you switch on your videos. Okay. Now, let us discuss these week 4 and week 5 questions from your lab cycle. Okay. Week 4 and week 5 from your lab cycle. Week 3, I told you to do. Okay. Note down the first question. Given a list of tuples, write a program to find the tuples which have all elements divisible by k from a list of tuples. So question is, see, there is a test list given over here. This is a sample test case. 6, 24, 12 is a tuple. 60, 12, 6 another tuple, third tuple. So if k value is 6, you have to give the output that if each element of the tuple is divisible by 6, then that tuple should be in the output. Okay. So 6, 24 and 12 all are divisible by 6, right? K value. So it should be there in the output. Similarly, 60, 12 and 6 are divisible by 6. So it is there in the output. But 12, 18 and 21, all the elements are not divisible by K value, that is 6. So that should not be there in the output. Understood the question? All of you understood the question? Switch on your videos. Vinay, switch on. Sujit. Write down the question. Shashank Reddy, H4. Shravan, Harsavardhan, A. Harsavardhan. Swapna, Siddharth Reddy. Fast, switch on your videos. Okay, have you written the question? Now, let us wait a minute. I will do 1 or 2 questions. Next, you have to try on your own. Okay. So try to understand this program. Given a list of tuples, write a program to find the tuples where the all elements which have all elements divisible by k from a list of tuples. So output will be again a list of tuples which are divisible by k value. Now, first thing you have to understand is how to create a list of tuples. How will you create a list of tuples? So we will write generalized way. First thing is I have taken a list here. Initially the list is empty. Okay. Understood? Next, I am asking how many tuples you want to create. So int of input of n value is nothing but the number of tuples I want to create. And k is nothing but the value with which I want to check whether it is divisible or not. So k is nothing but the value. The example may be 6 or 5 or 3 k value also you have to read. You have to write down a generalized program. Now, this is the for loop logic to create a list of tuples. How to create a list of tuples? So I'm writing a loop for I in range of n. N is what? N is nothing but the number of tuples. So if I want to create 5 tuples, so my loop should run 5 times. Okay. And here I am using tuple comprehension technique. So that's why I have written the tuple brackets. Then I am writing for every element x in input dot split, whatever you will read, that will be converted into integer and it will be stored into a tuple. Is it understood? Daily you are writing within square bracket int I for I in input dot split. Do you remember that logic? Similar way, just I have changed the bracket. Instead of the list bracket, square bracket, I have written here tuple bracket because I want to create the tuples. Is it understood? So one tuple is created at a time, and that tuple I'm going to append to my list. List is initially empty. So list dot append. I'm just including that tuple in, I'm just appending that tuple to the list. Is this thing clear? And then I'm printing my list. Okay. For up to this, let me run and show you. Okay. Enter the number of tuples. Suppose 3 tuples I want to create. Now enter k value. Suppose I want to divide each element of the tuple by 5. So what are the tuples I want to create? Suppose 5, 10, 15 is one tuple. Second tuple is suppose 12, 13, 14 is another tuple. Then another tuple is 10, 20, 30 is another tuple. So can you see here? Till now I have not written the logic for checking whether the elements of the tuples are divisible by 5 or not. I have just created an original list of tuples. So this is the first tuple, this is the second tuple, this is the third tuple. These are appended to a list. So for this, see the logic. For I in range of n value is nothing but the number of tuples. So I want to create 3 tuples, means this for loop is going to run 3 times. Now how to create a tuple? Tuple brackets I have given for x in input dot split. That means whatever the value, suppose I am giving 5, 10, 15. This is treated to be string. So each value is splitted, converted into integer, then it is inside a tuple. The tuple brackets are there. Okay. So 5, 10, and 15, it makes it as a tuple. Is this logic understood how to create a tuple T? Now, after creating one tuple, then you have to append it to the list. So I am writing list dot append tuple. That tuple you have to append. Okay, one tuple is created. Then for loop again runs for I is equal to 1. Now again the second tuple is created. Yes, you are reading how many input values? 3 input values you are reading. Okay, 3 or 4, any numbers you can give, that is splitted into integers. Then it is converted, splitted and then converted into integers. Then it becomes a tuple because of the brackets. Then append that tuple to the list. Hope it is clear up to this. Hope it is clear.
Yes, ma'am.
Respond.
Yes, ma'am.
Yes, ma'am.
Yes, Maruti, understood. Srivardhan. Shivani.
Yes, ma'am.
Okay. Next, we will talk about the logic. How to check that all elements of the tuple are divisible by k or not. What is the output asked? What is the output asked? Suppose my k value is 5. I have taken these 3 tuples. దాంట్లో ఒక్కొక్క ఎలిమెంట్ ఒక్కొక్క టపుల్ తీసుకొని దానికి 5 తో డివైడ్ చేయండి. If 5 is divided by 5, yes. 10 is divisible by 5, yes. 15 is divisible by 5. Then that tuple should be in with my output. A complete tuple output lo రావాలి. Suppose ఇక్కడ చూడండి 12, 13, 14 I have taken. 12 is not divisible, 13 is not divisible, 14 is not divisible. At least one element, if it is not divisible, that tuple should not come in my output. Is this clear? Is this clear? So
Yes,
for
ma'am.
that, different logic you can write. I have written here the list comprehension logic. Okay. What is that logic? You see here. So I want to prepare a final list of tuples. Okay. What is that? Can you see here? Now, first try to understand this logic. For T in LST, means what is the meaning? What is a list? List contains what? This list contains what? What is this list contains? It contains list of tuples. Yes or no? For T in LST means what? Each T is a tuple. Each T is a tuple. Is it understood? What? Yes, no. If I am writing for T in LST, LST is what? List of tuples. So T will be what? T will be one tuple from that list. Am I right?
Yes, ma'am.
Okay, one tuple from that list. So what I am checking over here? For that tuple T, I have written another for loop inside. For I in T, Means I will take the first value in this tuple and it is checking that I is divisible by k. This inner loop, what it checks for each tuple, for I in T means for each element in the tuple. Suppose my tuple is 6, 24 and 12. Yes, 6, 24 and 12 is my one of the tuple. So what is the value of I first time? What is the value of I?
6.
So first time I value is 6. So what it is performing? I modulus k. I modulus k means 6 modulus 5. It is checking 6 modulus 5. Can you understand over here? So just a minute. Okay. So this is my list. This is my first tuple. Yes, this is my first tuple. For I in T, what is the meaning? T is a tuple over here. What is that tuple? Is 6. Suppose it is 12 and 24. This is a tuple, suppose. So first time I value is this one. Index based it is. Second time I value is this one. Third time I value is this one, right? So for I is equal to 0. For I in T means we are talking about 6. Now what we are checking? Suppose K is equal to 5. What you are checking? 6 modulus 5. Is it true? No, it is false. Next time, I in tuple, second value, 12 modulus 5. Is it true? No. Third time, 24 modulus 5. Is it true? No.
False.
False. Okay. If my K value is 6, suppose, then for all the cases, I will get true, right? For all the cases, I will get true. That means this tuple 6, 24 and 12 should be there in my output, right? So what function is written? For T in LST means ఒక tuple తీసుకొని ఆ tuple కి ఈ rule apply చేయండి. For each element in that tuple, check all elements of that tuple are divisible by k or not. If it is satisfying, then keep it in the output. This is called the output tuple. That output is enclosed within list. That means finally it is going to prepare the list of tuples. Is this thing clear? Finally, it is going to prepare the list of tuples. So what is the condition we have written? If all tuples satisfy this condition, then keep this in the output. Okay. For each tuple, we are checking this condition, right? Like that, our list lo unna any tuples ee condition satisfy chestundi. A check chesi dani output list lo pettandi. Is this thing understood? Or I want to repeat? You want me to repeat? Anybody?
I'm repeating.
Okay. Which part you want me to repeat? The inner logic, right? Okay. So in this is called list comprehension technique we have used. Okay. In this list comprehension, you have to understand that my output is the tuples. And it is enclosed within square bracket. That means my output is list of tuples. I want my output as list of tuples. Right? Okay. For each tuple in list. So this is a list. This is an input list, right? This is list of tuples. For each T in LST means first time T is this one. Second time T will be second tuple. Third time T will be third tuple. So the for loop is going to run 3 times. Ante kada? For T in LST means first time my tuple is 6, 24 and 12. Is this clear? Right? For that tuple, inner bracket. Inner condition is what? If all, like that. Okay, all I'll discuss later. For that tuple T, can you see the variable here also T? For that tuple T, apply for I in that tuple. So for I in T, what is the meaning? If I modulus k is equal to 0, then you have to select that tuple. This line is same thing what I wrote here. For I in T means first time I value is how much? 6. 6 modulus. If k is also 6, 6 modulus 6 is equal to 0. Yes. Then second time, I value is 24. 24 modulus 6 is 0. Yes. Third time, I value is 12. 12 modulus 6 is 0. If it is satisfying, then that tuple will come in our output. Okay. How many times it is going to check? If all those tuples, all will return true when this inner bracket is true. Last time we discussed about all function and any function. If all are true, then it is true. So if the inner condition is true for those tuples, then all function will return true. Okay, and those tuples will come in the output. Second time, what will be the t value? Outer loop ki, inner loop tarvata malli outer loop ki vastundi. Second time t value will be another tuple 60, 12 and 6. Then for the second tuple, for each value I in t, again I modulus k, this logic will be applied. These two lines can be written in one line like this in comprehension. Comprehension means comprehensive way of writing. If you write, okay, let us try to write without using comprehension. Without using comprehension, how you could have written this? Can you tell me? How you could have written? I could have written like this: for t in LST, okay. Then inside this, for I in T, if I modulus K double equals to 0, then what do you have to do? What do you have to do? If it is satisfying, then final list and will take one list, final list, output. Final list is a list which is initially empty. Daniki a tuple append cheyali. If this condition is satisfied, come out of this for loop and write here final underscore list dot append. What you have to append? That tuple t you have to append. So I can write here tuple t. Just a second. I can append that tuple. Now it is understood. Is it understood now? After
Yes, ma'am.
append, if it is satisfying this, then append it. After that, it will go again to the outer for loop to check the second tuple. If it is satisfying, then append. If it is not satisfying, then don't append. So whatever the loop within loop you are doing over here, same thing using comprehension, it is written like this. Is it understood now?
Yes, ma'am.
Yes, everybody understood?
Yes, ma'am.
Sarvan, you understood?
Yes, ma'am.
Pati, Suchet, Maruti, Harsavardhan understood? Vinita Reddy understood, ma? Hemadri understood? Okay. So this is called list comprehension. If you do not want to use, you can go for loop within loop concept also. Okay. Then the list of tuples divisible by k, we are just displaying over here. Now let us run it again. Suppose number of tuples are 5. Enter k value is 3. Now enter the tuples 3, 6, 9. First tuple 10, 12, 15. Second tuple 5 tuples, right? 15, 18, 21. Third tuple. Then 3, 4, 5. Fourth tuple. Then 3, 6, 10. Okay, these are the original tuples which are divisible by 3. Only these two tuples are entirely divisible by 3. Hope this program is understood, all of you.
Yes, ma'am.
Please write down the code. Swapna understood, ma? G9 Swapna.
Ma'am,
Yes, ma'am.
Yeah, tell me.
ma'am, where you will save that you are giving the tuples different, right, ma'am? From line to line.
Yes.
Where it will store it them?
You see this line, list dot append. It is storing into a list.
No, ma'am. Before that, you are giving it like you are not even telling input function to for that tuple. You are
Here I
just
have
asking
written.
number of tuple and number.
Here you see in the loop input dot split function is written.
Okay, ma'am.
Read the input. Now it is
Every
clear.
time it goes one loop, it's gonna ask us.
It is every time one tuple is created.
Okay, ma'am.
So for that tuple input function dot split. Okay.
Okay.
Right. Today week 4 and week 5 we will complete, and you need to upload 1 to 5 lab records. You should upload. Week 1 and 2 also you didn't upload, I guess.
Like screenshot we have to upload, ma'am.
Not screenshot. That worksheet that you are writing, you have to make it PDF after writing the worksheet, and that PDF of your worksheet you need to upload in your login. Your day-to-day lab is there, na? You select Python programming lab, and week 1, week 2, you have to upload.
Ma'am, what about dates?
ఏ వీక్ మీరు ఏది చేశారో అది రాయాలి, ఆ డేట్స్ రాయాలి.
Ma'am, they are not corrected now.
If you will upload, then only you will correct online.
Okay, ma'am.
Okay, this 5 weeks we will correct it online. So when it becomes offline, you bring those files to us. We will also write down the same marks. Okay na? If it is going on offline, then correction అయిన తర్వాత upload చేయాలి. First and second weeks you have not shown, right? Completed. Shall I go for next question? Pranati, over ma. Next question, see here. Second question is, given a list of tuples, write a program to filter all the tuples which are having uppercase characters from the given list of tuples. Is it a similar question? See, this tuple is having all uppercase. This is not having. This is having. So you need to find out only the tuples which are having all uppercase characters. Okay. What is common in both the questions? Can you tell me? What is common in both the question? Given a list of tuples. That means you have to create these kind of list of tuples. Is this thing clear? Now, can you see over here? I'm asking the number of tuples. Okay. So that many times my for loop will run. Same logic I'm writing. Initially, I have taken an empty list and I'm creating one tuple. In that tuple, what are the things that each element is a string? So I'm converting each element into a string. So for I in input dot split, convert those elements into string. Okay. Then can you observe the bracket is there outside? This becomes a tuple T. Then that tuple you have to append it. That tuple you have to append it. Okay. So this is your list of tuple creation for this kind of test case is ready. Understood? Okay. Now next what is asked? Question is asked to filter out all the tuples which are containing all uppercase characters. Which are containing all uppercase characters from a given list of tuples. Hope it is clear. So can you apply the same logic over here? Here the question was the elements which are divisible by k. But here the question is check the characters which are uppercase or not. So instead of only this line, there is a built-in function called is upper. Okay, that is upper, if that element in the tuple is uppercase, then it is going to return me true. So I can, just a minute, I can copy this 3 lines. I'll tell you both ways, without using list comprehension and with using list comprehension. Let me put this in comment line first. Right. So up to this is understood, right? List of tuples is created, right? Now, now it is telling you to filter out only the tuple elements which are uppercase. So instead of writing this logic, you can just write the method is upper. That means for I in tuple, for each element in the tuple, if it is upper, if it is upper means that character that is uppercase or not, it is checking. If it is upper, then keep that tuple in the output. Okay, let us run and see. Suppose number of tuples is 2. A, B, C is one tuple. Number of tuples, right? Okay. Then A, B, C. Okay. Now it has identified and it is telling you the uppercase tuples are like this. So this is one way of using list comprehension. Understood this? Yes? Okay. I will not go for list comprehension. So I'll put this into comment line. Now I'll go for normal loop technique. Okay. Up to this list of tuples is created. This part is understood. Respond yes, no, what?
Yes, ma'am.
Next, I am going to make one final list of tuples which are uppercase. So what I am doing for I in LST, what is each I? What is the value of I? Tell me what is the meaning of I here?
First value.
What is that value? I means I is a tuple. I is a tuple over here. Because what is this list? This is a list of tuples. Yes? How will you imagine this? This is a list of tuples. List of tuples over here. This is third one, this is fourth one. This is a list. So first time I is what? First tuple. Second time I is second tuple. Third time I is third tuple. I'm talking about I is a tuple here. Hope it is clear. Next, I have taken a flag variable. Result is true. That means I am imagining that the tuple contains all capital letters. So it's just a flag. It's just a flag. Initially that is true. For J in I, what is the meaning of J in I? Suppose just a second. Take LST is initially suppose A, B, C, comma, A, small p, small q, something like this, okay? Something A, Q, R or something like this. This is my list. So for I in LST means first time I is this tuple. I is this tuple. This is the meaning of this. For I in list means, okay. Now we have taken a flag variable which is initial result is true. Don't worry about this. For J in I means what is the value of J? First tuple I am talking about. This is A, this is B, This is C. This is my I. For J in I means first time J is A, second time J is B, third time J is C. For J in I, if J dot is upper, that means you are checking this character J, that A is upper or not. Is upper will return you true or false. So if A is uppercase, this is going to return you true. I'm checking if J is not upper, if J is not uppercase, then you have to make result is false and you have to break it. What do you mean by this? First time, suppose it is small letter undema. First time J itself is not uppercase. Then you need not check the other two values. Is this understood? For J in I means first time J value is small a, suppose. If that small a is not uppercase, then break the loop. That means no need to check the other two values in that loop. It is breaked over here. Is it understood? Now, if it is breaked, where it will go? It will go to outer loop. Again, I in LST, that means now I becomes the second tuple. Now I becomes the second tuple, A, P, small p. Imagine this is small p and this is small q. How it will run now? Tell me. For J in I, now J becomes capital A. J becomes again capital A. That is uppercase kada, not uppercase, false kada. So result is still true, break avadu. Second time J value becomes P. Second time J value becomes small p. Okay. P is not uppercase, so the loop will be breaked here. The loop will be breaked over here. It is not going to check this third element. Second time, so it is breaking and it will go to the outer loop. Again I. What is the value of I? Third time I will be third tuple, that is capital A, capital Q, capital R. This is third time I value. Now again J in I, again J will be A. Okay, is it uppercase? Yes. The second time Q uppercase? Yes, uppercase. So this flag is not going to be false for the third tuple. Is this thing understood? Now 3 tuples checking is over. Now you check finally the value of if anywhere it is up, anywhere it is false, then that is not going to be append. If result is true, then that tuple, here that I value is nothing but our tuple. Each I value is a tuple. We are going to append to our final list. Is this thing understood or shall I repeat? I want to know. Students, respond.
Understood, ma'am.
Understood, everyone?
Yes, ma'am.
Musra?
Ma'am, can you please repeat here
Yes.
from
Where it is not understood, tell me.
for J in I?
For J in I. Each time I is a tuple, you understood?
Ma'am, tuple we'll take I as tuple.
I will be a tuple. That tuple is containing suppose 3 elements. Okay? Suppose it is containing 3 elements. Just wait. Okay. Now, first time I suppose this tuple, right? For J in I means each element of this tuple. This is a tuple, right? What is that tuple I am talking about? I am talking about this tuple. For J in I means I am iterating that tuple. So first time J value becomes
Capital A.
J value is nothing but A first time. That A is uppercase or not, I am checking. If first time itself J value is A, right? If it is not uppercase, then this flag is going to be false. But if the uppercase kada, result will not be false, right?
Yes, ma'am.
Yes, it is not false. Then again the loop will run. Second time, what is the value of J? J value becomes B. B is uppercase kada. So these two statements are not going to be executed. Third time, J value is capital C. So these two statements are not going to be executed. Not upper aithe result variable false avutundi. But it is upper. So this variable is, these two statements are not going to be executed. Hope it is clear.
Yes, ma'am.
Right. So all are uppercase. If all are uppercase, then loop is not breaked. If all are uppercase, then I'm checking what is the value that is still there in result. Result was initially we made it true, right? Now after checking J value 3 times also, result false avaledu kada. So result is still true. If it is still true, then that particular tuple I am going to append to my final list. To my final list, that particular tuple, which is nothing but I here, is going to be appended. That means this particular tuple is going to be appended to my final list. Final underscore list is going to contain my first tuple as A, B, C. Now try to understand. Second time, suppose it is small a, capital P, small q. It is there like this. Okay. Second time, what is the value of I?
Small a.
Second time.
Second tuple. Second tuple.
I'm not getting your voice. Okay. Second time, what is the value of j in I?
Small a.
Small a. So here it is small a. Okay. Is it upper? No, it is false.
No.
If it is false, then result becomes false.
False.
And the loop is breaked. That means this loop was supposed to run 3 times, right? For j value A, j value P, j value Q. So it is not going to run, it is breaked. And when you come out of this loop, I'm checking what is the value of result. What is the value of result? We have made it false.
False.
If it is false, then this statement will not be executed. Append operation will not take place. Okay. Then after this, it is again going to outer loop. That means if the first one itself is false, it is not going to check these two. Then it is going to run the third one. Third time, I is this one. Suppose here Q is small letter. So A is capital letter. Okay?
True. Yes.
True. But second time Q is false. So it is going to break. Okay? Result is going to be false. So it is not going to append. This one also. This one is not going to be appended. This one is not going to be appended. Only this will be in my final list.
First tuple.
Is clear? Mr. It is clear?
Now it is clear. Yes, ma'am. Now it is clear.
Now it is clear, right?
Yes, ma'am.
This is called without using list comprehension logic. List comprehension logic is very easy here in one line. 2 for loops, loop within loop you have written. Okay? Okay, this way also we will try to run it. Number of tuples are 3. Take some characters. Okay, so in the filtered list of tuples, only one tuple you will get the output. Okay, make it fast. Last question. Last question is, given a tuple and a list, write a program to find the occurrence of, to count the occurrence of all items in the list in the tuple. It's a very small question. All occurrences of all items in the list in the tuple. How to do this? See, input is one tuple and one list. How to read, how to create a tuple and a list? Here I am using T is a tuple I want to create. See, all of you remember, you can use tuple method. Otherwise, simply put the tuple brackets. How we have created a tuple here? Not here. Okay. Here. This way also one tuple can be created. Yes. If you do not want to do this way also, you can write the tuple method to create a tuple. Inside this, you are reading the elements of the tuple dot split. Right? Similarly, you can use list comprehension always to square bracket use chesi rayachu. Otherwise, you can write list of read the elements dot split. So it will be converted into a list. So one tuple I am reading, one list I am reading. Then I have to check the occurrences of each element of list in tuples. So for I in L is a list. For each element I, for each element J in tuple, if both I and J are same, that means list lo element undi, tuple lo kuda ade element undi. Rendu same aite, then I am incrementing my counter. Is this thing clear? If the occurrence of list, that means if the element appears in both list and tuple, then you count it. It is available in both. Then total occurrence is the counter value you have to display. Okay. Enter elements into the tuple. Suppose the elements are A, B, C, D, E, A, something like this. Elements of the list is A, F, C. Which elements are there? Total occurrence. A is there. List elements we are checking in tuple. List element A is there. Yes, A is there twice. So 2 times counter increment aindi. F is there, not there. C is there. Yes, it is there once. So total occurrence of list elements in tuple is 3, right? Is this understood?
Yes, ma'am.
Yes?
Yes, ma'am.
Musarraf, understood or not?
Yes, ma'am. Yes, ma'am.
List lo unna prati element we are checking in the tuple. I in L means we are taking each element of the list and we are taking each element of tuple. We are comparing, are they same? If it is same, increment your counter. First time, list element A and tuple element A. So, A ki nu tuple lo unna prati element to compare chestunnavu. You are comparing this first element I in L. We are comparing with all the elements. Inner loop will run how many times? Inner loop will run from beginning to end. For each element of J in T, that means this one element A is compared with all elements of tuple. And that A is appearing. If I is equal to J, this A is present twice. So counter will be incremented twice. Okay. Once that tuple is over, then it goes to the outer loop for I in L. That means second element of I is F. That is compared with all the elements of tuple. If there is a matching, if I is equal to J, then that counter is incremented. Third time I becomes C. It is compared with all the elements of the tuple. Whenever there is a matching, C is matched once. So counter is incremented. Is this logic understood?
Yes, ma'am.
Element of the list I am comparing with the tuple and then I am incrementing my counter. Hope I am clear. So these three programs we have completed today. Hope it is understood to you.
Yes, ma'am.
Yes, ma'am.
5 we will do next class. Time is not sufficient. Respond to your roll calls. D1.
Present, ma'am.
D2.
Present, ma'am.
D3. D3 absent. D4. D4 absent. D5.
Present, ma'am.
D6.
Present, ma'am.
D7.
Present, ma'am.
D8.
Present, ma'am.
D9.
Present, ma'am.
E0.
Present, ma'am.
E1. E1 absent. E2.
Present, ma'am.
E3.
Present, ma'am.
E4.
Present, ma'am.
E5.
Present, ma'am.
E6. E6 absent. E7.
Present, ma'am.
E8.
Present, ma'am.
E9.
Present, ma'am.
F0.
Present, ma'am.
F1.
Present, ma'am.
F2. F2 is absent. F3.
Present, ma'am.
Evarama F2. On J video on J.
On Jason, ma'am.
Okay. F3. F3. Absent. F4.
Present, ma'am.
F5.
Present, ma'am.
F6.
Present, ma'am.
F7.
Present, ma'am.
F8.
Present, ma'am.
F9. F9 absent. Next series. G, G naught.
Present, ma'am.
G1.
Present, ma'am.
G2. G2 absent. G3.
Present, ma'am.
G4.
Present, ma'am.
G5.
Present, ma'am.
G6. G6 absent. G7.
Present, ma'am.
G8. G8 absent. G8.
Present, ma'am.
G9.
Present, ma'am.
ఏంటి ఇద్దరు G9 ఎవరమ్మా ఆన్ చేయండి వీడియో ఆన్ చేయండి G9
G9 present, ma'am.
G9 H0
Present, ma'am.
H1
Present, ma'am.
H2
Present, ma'am.
H3
Present, ma'am.
H4 వీడియో ఆన్ చేయండి H4 H4 is absent H5
Present, ma'am.
ఆన్ చేయి వీడియో ఆన్ చేయి H5
On, ma'am.
ఓకే H6
Present, ma'am.
H7 H8
Present, ma'am.
H8 ఎవరమ్మా
Present, ma'am.
I'm not getting you H9
Present, ma'am.
H9
Present, ma'am.
I can't see you H9 what's your name
MV name, ma'am.
okay K naught
J not, ma'am.
G naught J naught huh?
Yes, ma'am.
J naught
Present,
who is J naught
present, ma'am.
J1 J naught okay
Name.
okay J1
Present, ma'am.
J2
Present, ma'am.
J3
Present, ma'am.
J4
Present, ma'am.
J5
Present, ma'am.
J6
Present, ma'am.
J7
Present, ma'am.
J8
Present,
J8 J9
Present, ma'am.
J9
Present, ma'am.
K naught
Present, ma'am.
K1
Present, ma'am.
switch on your video K1
Present, ma'am.
K2
Present, ma'am.
K3
Present, ma'am.
K4 K4 last right K4 who is K4 K4 absent okay okay next faculty has joined students what is the subject you have
Chemistry, ma'am.
okay
Prasad, sir. He's wrong.
okay sir is there
Present.
Yes, ma'am.
okay fine
Sir,
Morning, sir. Good afternoon, sir.
Good afternoon, sir.
good afternoon. Good afternoon.
సార్ మిమ్మల్ని హోస్ట్ చేశాను నేను ఒక 10 minutes లో వస్తాను నెట్ ప్రాబ్లం ఉంది పవర్ పోయింది మళ్ళీ
Okay, okay, okay. Got it.
Sir,
Okay.
sir, excuse me, sir.
This is audible.
Sir.
Syed, this is audible.
Yes, sir. Sir, can you repeat yesterday's topic for some extent? Means about cation exchange and some.
But do you want to again repeat the topic?
No, sir. I want just a brief some.
Yes,
Want to know-
benzene. That's.
You want some clarification from the topic?
Yes,
Yes,
sir.
sir.
Okay, okay, okay. So ionic change process, right?
Sir.
Musharraf,
Yes, sir.
okay. Please. Do you need explanation once again from the topic? Or you need any clarifications from that?
Sir, explanations.
Oh,
I didn't understand.
okay, okay, no problem.
Not so brief. Just you explain
Oh, sure, sure,
what
sure.
are the methods.
Okay. There's nothing. Okay, anyway. So, ionic change process. It is a one type of external water treatment method In external water treatment method, there are some of the treatment methods are there. Ionic change process and reverse osmosis process and chemical precipitation process, filtration, ultrafiltration technique. These are the techniques to getting soft water from hard water. So regarding this, ionic change process are very powerful method to purify the softening of water. Because this ionic change process, demineralization process. Based on the contaminants, we are going to use different type of methods to softening of water. So demineralization process means if water having any heavy contaminants, inorganic contaminants, I mean cations, anions, heavy metals, if you present that type of minerals is present, we are going to demineralization process. This demineralization process to control the mineral in the water system. I mean, so there is some hot water, if you hot water, there is some calcium, magnesium, sulfates and chlorides, bicarbonates is present. So not only calcium, magnesium, iron, aluminum, this type of metal salts is present. We are removing that type of hard metals, hard cations, hard anions from this ionic change process. That is the advantage of ionic change process. Industrially wastewater, especially having this type of contaminants. So that's why this ionic change process are industrially wastewater purified technique. Industrially wastewater purifying technique. Ionic changers are, it is a one type of organic polymers, because especially these organic polymers having microporous structure, and these organic polymers, it is a copolymers having some functional groups. These functional groups having the capability of exchange of ions. So that's why we are saying some of the copolymers act as a cation exchange reagents. Some of the copolymers act as a anion exchange reagents. If cation exchange reagents is present, if simply exchange to the some of the replace to the some of the cations, that is calcium, magnesium, iron, aluminum, this type of metals is possible to exchange using this type of technique, cation exchange reagents. And anion exchange reagents is having some anion functional groups. These functional groups is exchange functional groups to exchange the anions. That means chlorides, sulfates, bicarbonates, and any bromides, this type of anions easily exchanged, easily reversible to use these anion exchange reagents. So anion exchange reagents, cation exchange reagents, chemical equations also we are discussing. If you see this cation exchange reagents, RH means, R is resin. H means that is the anchoring group. That means functional group. If that anchoring group, please.
Sorry, resins are polymers.
Yeah, resins are polymers. Resins are polymers. That polymers having some functional group. I am showing the picture of a resin chemical structure. If you see the chemical structure,
we are like
yeah. This is a styrene divinyl benzene copolymer.
We cannot see the PPT, sir.
Sir, we can't see your PPT.
PPT is not showing.
Yeah, no, sir. We cannot see.
Okay, please. 1 minute. there any problem? One minute. I shared.
It is showing.
Yes, sir.
It's fine. This is the chemical structure of cation and anion exchange resin. This is the normally basic chemical structure. If you look at the structure, this is the styrene divinyl benzene copolymer. If you see, there is a benzene rings is present. Vinyl group means it is the double bond structured compounds. We are using this vinyl groups, keto group. The keto group, we are saying vinyl group. Acetylene, and methylene. These groups are vinyl groups. Double bond. If a carbon double bond is present, that groups we are having vinyl group. We are saying that vinyl group. So that is a benzene vinyl group is present. From that we are getting this polymer. So that's why we are saying styrene divinyl benzene copolymer. If this divinyl benzene copolymer having some functional groups, anchoring groups, SO3 minus, Na plus. So these are the functional group. SO3 minus is the functional group. This functional group attached some cations. So Na plus is the cation. So that's why we are saying cation exchange resin. Similarly, quaternary ammonium salt is attached in the divinyl benzene copolymer. So it's act as a anion exchange resin. Please, any doubts from there? Syed.
I'm clear. No, sir.
Are you following?
Yes, sir.
Very good.
Because of Na+, we are calling it as a cation exchange resin. Because of OH minus, it is anion exchange resin, right?
Yes, simply that's it. That's it. Because the functional group having cation, if you have the cation, only the sodium plus ions only exchangeable. So that's why we are saying that is a cation exchange resin. If a sodium is a replace, sometimes it's having H plus ions. Sometimes we have to use only H plus ions. That means sulfonic acid cation exchange resin. If a sodium sulfonic divinyl copolymer cation exchange resin. Here the sodium presence of cation exchange resin. Sodium is nothing happened in the water, because hot water means only calcium, magnesium, iron, aluminum, sulfates, chlorides only to get that hardness, to give the hardness. Sodium doesn't give the hardness, because some ppm level of sodium is permeable to take drinking level. So that's why sodium doesn't happen in that doesn't give the hardness to the water. So that is a biocompatible material. Sodium. We are also using the sodium chloride in food also. We are taking food from food also. So that is nothing to problem. So that's why these sodium plus ions only exchangeable. The sodium plus ions is exchanged to the calcium or magnesium or iron, whatever it is. Mainly calcium, magnesium are focusing, because the hardness causing cations is calcium and magnesium. So that's the reason we have to exchange that. We have to remove that calcium, magnesium. So that's the reason we are using cation exchange resin. And the second one, there is a quaternary ammonium salt, OH minus ions groups is present. These OH minus ions groups to exchange anions. Anions means the hardness causing anions. Which are the hardness causing anions? That is sulfate anion and chloride anions. These sulfate, chloride, bicarbonate anions is exchangeable through these OH minus ions in the resin, So that's the reason we are saying this is anion exchange resin. It's very simple. So that exchange capability depends on the polymer structure. So that's why we are going to study the structure of polymer, copolymer. If we anchoring groups is a more, if a functional structure, cross-linking structure is a more, then that copolymer is having very good water stability. I mean, some of the normally these polymers are insoluble in water. The stability is a more. And if we having cross-linkings or functional groups is a more, then that resins, that copolymers having the possibility of removing of cations and the anions is enhanced. So that's why we are saying that capacity of resins is increased. So that's why, so that is another phenomenon. So capacity of resins is, it depends on the functional group of copolymer, the functional groups present in the copolymer, and the cross-linking of the copolymer, the stability and the removing capability and hydrophobic nature, hydrophilic nature. This is the depends on the structure of copolymer. Based on that, we are going to synthesize a different type of copolymers, and we are functional, we are attached to the functional groups. That attached functional group of copolymers having higher capability to remove the ions, cations and anions. So that is the advantage of, especially in anion and cation exchange resins. If industrially also and domestic way also, there is a two containers is there. One container is anion cation exchange bed tank, and another one is the anion exchanger column is present. The column or tanks is present, depends on the quantity of water purification softening technique. We are using different columns or tanks. So that columns, so first column is having cation exchanger bed and second column is having anion exchanger bed. When hot water passing in that cation exchange resins, the cations, hot causing cations only exchanged in this process. Then, so the removed hardness of cations, that means calcium, magnesium, iron, this type of cations. When the removed, that removed hot water is passing through the anion exchange resin. In that column, the chlorides, anions is exchanged in that resin. So what happened? The pure water come out from that tank. This is the process happened in the ion exchange process. And then after that, after usage, number of usages, we have to regenerate of that cation exchange resin and anion exchange resins. So using if you want to reuse the cation exchange resins, we have to use HCl and H2SO4. If you reuse the anion exchange resin, we have to use and sodium hydroxide, potassium hydroxide, basic solutions. If you use basic solutions, then we have to remove that sulfates, chlorides, this type of anions in the anion exchange resin. This is the regeneration of exhausted bed. So that is the advantage of reused this type of resins in the columns. Any doubts there?
No, sir. Sir, now when we are passing hard water to cation exchange resin, so where that cations will go? So you're taking first cation resin, then after you're taking gravel. So where that hard cations will
go? Actually, what happened? This resin is already we discussed. The resin, this polymer having hydrophilic nature, hydroscopic nature. Sorry. So due to that reason, what happened? The cations, the hardness caused cations is attached on the surface of the resin. Is attached. We cannot remove it from there. It attached on the surface of the resin, because comparatively this H plus ions and sodium plus ions, calcium, magnesium having more coordination bond with these resins. So that's the reason this calcium and magnesium easily replaced the which cation exchange resin having H plus ions or sodium plus ions, it can remove from the resin, and that place the calcium and magnesium is attached on the resin. This is the happen in the cation exchange resins. Similarly, in anion exchange resin also same phenomena has happened. So the chlorides and OH- ions easily removed from that anion exchange resin. The chlorides and sulfates is attached on the surface of the anion exchange resin. So when we are not getting the proper exchange, ion exchange process, we are not getting proper water, softening water. That means the bed, the ion exchanger are filled with some heavy metals, hardness of cations or anions. Then only when we are following, so the regenerate of the ion exchangers. Once a month, if you regenerate the ion exchange resins, again that resins are reusable to softening of water. That is the advantage of the ion exchange resins. Sayed, are you okay?
Yes, sir. No, okay. So they will settle on the surface now. Yes.
Settle on, yeah, should be. It should be settled on the surface. It is not settled because there is some process. It is anchoring. It is a bonding. So that is a cation anion bonding.
It makes it bound with that and release an hydrogen.
Yes,
it
can release the hydrogens from that.
So it will be bound to that only, to the bed.
Yeah, sure. It should be. It should be. It's a process. Okay. Are you okay?
Sir, no. Okay, sir.
Okay, thank you so much. Nothing to worry about that.
Thank you, sir.
Understand, I'm very happy. Now we are going to discuss another softening method, that is a reverse osmosis method, and geolite water softening process method. So reverse osmosis and geolite water softening method. So slide is sharing.
Yes, sir.
Oh, fine. So reverse osmosis method. So see that this is the one of the softening technique. So now why we are going to reverse osmosis method comparatively ion exchange technique. There is a demerits is there ion exchange technique because total demineralized is happened in that water softening method. We are not getting the mineralized water. Once if you use ion exchange method, so almost 5 ppm below 10 ppm of water we are getting. So the demineralized means we are not getting the macro and micro nutrients to our body. That is the drawback. But in industrial purpose, it is a very useful because there is a when we are using that in steam generation. So this water, that demineralized water, not getting any sludge and scale. That is the advantage of that ion exchange process. But our people also some moderate ion exchanges we are using. This process we are continuously using in domestic for drinking purposes also. You understand what I'm saying? Syed?
Yes, sir.
Yeah. Desalination process, it is the process to removing the salts like sodium chloride, sodium bromide, this type of salts we are going to remove from this desalination process. From the water, if you water having more salt contaminates, then we are following this process, reverse osmosis method. So this reverse osmosis method is just like we are using for water purification for desalination process. Normally, the water containing heavy dissolved salts with salty or brackish taste, when the water having the brackish taste, so that it is called as a brackish water normally this technique is also applicable to the brackish water also. So brackish water purification also we are following this reverse osmosis method. If you see this fresh water, the ppm of TDS value is 1000 ppm. Brackish water, sir, Santosh Singh sir, please. Brackish water, it contains more than 1000 ppm to less than 30,000 ppm. And seawater, it contains more than 30,000 ppm of dissolved solids is there. TDS is a more. If a TDS percentage is a more, so that's why we are using this reverse osmosis method for brackish water and seawater purification. So all coastal areas, coastal countries, they are following this reverse osmosis method to purify the softening of water. Seawater and brackish water can be made available as a drinking water through this desalination process, this reverse osmosis method. Desalination is normally carried out reverse osmosis and electrodialysis process. There is a two wonderful techniques is available. Reverse osmosis and electrodialysis method is available. In your syllabus, we are going to discuss reverse osmosis method. Reverse osmosis method is nothing but one type of membrane filtration process. Is nothing but one type of membrane filtration process. So this process, when we are using this water softening technique, so then we are getting that the method is called as a reverse osmosis method. Normally, what is osmosis method? If you have two solutions, if a container having, if you see this picture, this is the equal concentration. There is the container is there in first figure. There is a dotted line I am presenting there. The dotted line is a representation to the semi-permeable membrane. Semi-permeable membrane. There is a two sides. There are two type of solutions is present. If a same concentration of solution is present, so there is a equilibrium solution is a non-transferable ions if you present, that is a equilibrium concentration of solution is present in the both sides. If you look at this osmosis method, there is a permeable membrane is there. One side is a low concentration of solution, and another side is a higher concentration of solution. What happened? Due to the osmotic pressure, low concentration of solution is diffused to migrated from low concentration to higher concentration. So this method is called as a osmotic pressure, osmosis method. Osmosis method, what happened? In the permeable membrane, the ions will move to low concentration to higher concentration. Then what happened? If a reverse osmosis method, if you applied any pressure in the lower concentration, in higher concentration, so what happened? The higher concentration of ions to move to lower concentration. So this is happened in the reverse osmosis method. Reverse osmosis method is a wonderful technique to remove the all type of ions and microorganisms. So that is a very popular method. If you see this picture, reverse osmosis cell consists of a chamber fitted
Can you
with
show me a previous slide, sir?
Please. This is equal concentration on both sides, first figure. If equal concentration both sides is present, there is nothing happened. The solution cannot exchange. I mean, the solution having ions cannot exchange from one side to other side. If you present in semi-permeable membrane, this is the when we are using semi-permeable membrane. So then only we are looking osmosis process. If a semi-permeable membrane is present, so there is a different type of concentration of solutions is there, lower concentration and higher concentration. Due to the osmotic pressure, lower concentration of ions to move to higher concentration. If we applied any external pressure in higher concentration, what happened? The process, the osmotic process is reversible. So higher concentration of ions to move to lower concentration level. So that process is called as a reverse osmosis method. So sometimes we are also called as this is the super and hyper filtration process. Super and hyper filtration process. See that somebody last class they are asking some question. What is a dialysis, sir? What is this is osmotic? Osmosis is a different. Dialysis is a different. Osmosis and diffusion is a different. Diffusion means the ions to migrate, to move, to migrate lower concentration to higher concentration without any permeable membrane, any semi-permeable membrane.
Diffusion occurs in gases only. No?
Diffusion occurs not only gases, any ions. Gas, not only gases, ions also diffused. Due to the reason current also we are going to generate it. So if you cations, anions is a present, ion will go to diffuse. Gases also it can diffuse. Osmosis also, in osmosis process also, osmosis process means if the presence of permeable membrane, so what happened, the ions move to lower concentration to higher concentration. The pressure is called as a osmotic pressure. The ions only move to that permeable membrane to control the ions. Ions, it can only move to from lower concentration to higher concentration. And reverse osmosis method, what is the reverse? Reverse means we are applying some external force, external pressure. When we are applying external pressure in a higher concentration way, higher concentration side, then what happened? So low, that permeable membrane to allow to transfer some of the ions higher concentration to lower concentration. This principle is involved to the water desalination process. So that's why this technique is also called as a super and hyper filtration process. Super and hyper filtration process. So see this is also method. So I'm showing the color. What is the color? Coloring. So there is a contaminants of water is present and non-contaminates pure water is present on the other side. There is a permeable membrane is present in the U to U shaped tube is present. I'm showing then the center, the semi-permeable membrane, brown color I'm shaping there. So what happened? Normal osmotic pressure. So due to the osmotic pressure, the pure water contaminates, some of the ions to move lower concentration to higher concentration way. So when we are going to apply the pressure, external pressure in higher concentration way, so what happened? So there is a permeable membrane to transfer to the ions. Only that permeable membrane only to the allowed to the only some specific macro sizes of the ions. That ions can move to higher concentration to lower concentration due to the external pressure. So what happened? One side, the majority of the higher contaminants is present. So only the membrane, through membrane, pure water is transferred to the semi-permeable membrane. This process is happened in the reverse osmosis process. So it's a wonderful process. So we are applying, depends on the contaminants, different type of atmosphere we are pressuring, we are applying to purify the water. If you use the seawater, we are applying different type of external pressure. So if you brackish water, if you applying brackish water through brackish water, so we are applying different type of pressure. So normally these membranes are very thin films and cellulose acetate, and some of the superior membranes we are made up with synthesized, synthetic membranes are also available. That synthetic membranes are polymethacrylate and polyamide polymers. These two type of membranes are also we are using, synthetic membranes also we are using to filter the desalination process for semi-permeable membrane. So natural membrane is a cellulose acetate. So membrane, cellulose acetate is a semi-permeable membrane. It acts as a semi-permeable membrane. And some of the synthetic membranes also there, that is the polymethacrylate and polyamide polymers. Polyamide polymer. These are the combinations are there. Some of the combinations of organic polymers also, it's act as a semi-permeable membrane to allow to transfer the ions. So this is the reverse osmosis method process. I will show the little bit of video after finishing this reverse osmosis method, how now the technology people that they're following the reverse osmosis, how they developed synthetic membranes to purify the water. So before going to watching the video, what is the advantage of reverse osmosis method? Main advantage is the ionic and non-ionic colloidal particles and higher molecular weight of organic matter and some of the pathogens also we are going to remove from this technique. And it is very wonderful technique to remove the silica particles also. Geolite process and ionic change process also is not possible to remove the silica particles. But this reverse osmosis technique is a wonderful technique to remove the silica particles also. The lifetime of semi-permeable membrane is very high comparatively geolite and ionic change reagents. The lifetimes, the usage capability is more comparatively ionic change reagents and geolite process. Membranes can be replaced within few minutes. So it is commercially available, this type of membranes. So we can easily remove. If we see this intlo purified water purifier, there is a 2 cylinder types uses. The big columns and is ionic changers. Top of the filtration meter, so there is a roller type that is the reverse osmosis filters. What name? Reverse osmosis filters. That reverse osmosis filter we can replace very easily, but it's more than 2 years, 3 years it can workable, that reverse osmosis filters. So, and also it is a cost efficiency, it's a low cost available, and that is a reliability, that is a high reliability. That is another advantage of this, especially this reverse osmosis method. Can you watch this video? What is the main advantage of reverse osmosis method? How we are going to desalination process happen in if we use this reverse osmosis. This is one of the LG people, technology people, they made this video. Please watch this. Then if you have any doubts, you can ask me.
Increased water production for a major desalination plant in Chile by 17%. Reduced energy consumption for one of the world's 10 largest seawater desalination plants. LG Chem, a world leader in thin film technology with over 22,000 employees worldwide, is changing the future of desalination. Reverse osmosis is today's leading technology in addressing water scarcity across the globe. Osmosis is the movement of liquid with low particle concentration through a semi-permeable membrane into a region of high particle concentration to achieve equilibrium. Natural osmotic pressure then maintains this equilibrium. Reverse osmosis is the process of applying pressure greater than the natural osmotic pressure to force water to travel through the semi-permeable membrane from higher concentration to lower concentration. This process is widely used today in desalination plants across the world to produce potable water from various sources. The efficiency and effectiveness of this reverse osmosis process lies in the flux and rejection capabilities of the membrane. LG Chem's innovative and patented nanocomposite technology produces the industry's most efficient reverse osmosis membranes for desalination. LG Chem's full portfolio of seawater and brackish water reverse osmosis membranes feature benign nanoparticles embedded into the top polyamide layer of the thin film membrane. This proprietary nanocomposite material increases the membrane's throughput and productivity while delivering best-in-class salt rejection. This is what the products are, which has LG Chem's nanoparticle technology applied. LG Chem leads the industry with its high rejection seawater and brackish water RO membranes, including anti-fouling, which deliver up to 99.85% salt rejection. For durability and performance in high fouling applications, LG Chem also offers a line of high flux and high rejection anti-fouling brackish water RO membranes, which feature its unique nanocomposite technology. LG Chem's global network of sales offices and distribution centers ensures quick access and delivery. From Asia to the Middle East, throughout Europe and the Americas, LG Chem's team of sales and application engineers are ready to support each project from start to finish. LG Chem's Q+ projection software and QC normalization programs are widely considered to be the most intuitive and comprehensive tools in the industry to helping customers maximize the performance of their RO system. LG Chem's technical service engineering team is always ready to support new installations, system operations, and maintenance across the globe. More water, less energy. This is LG Chem's promise to making the world cleaner and greener. For more information,
Did you understand what is reverse osmosis method based on the video at least? How the technology people, they are developing the different type of membranes to purify to softening the water.
Yes, sir.
Any doubts from our reverse osmosis method?
No, sir.
So we will go for geolite process. Okay.
Sir, in reverse, sir, in osmotic osmosis topic, we have problems related to osmotic pressure. In
Yeah,
exam.
we can go to discuss this numerical problems, especially in this topic. So what the numerical problems is maybe is possible in the raise the questions. We'll go to discuss this Monday, coming Monday. Monday we have 2 hours, right? So we will go to discuss on Monday. Okay.
Okay.
Definitely we'll go to discuss. And if you have any doubts, especially in reverse osmosis method, you can ask me. We will go to discuss. Otherwise, you can continue to this geolite process. So anyway, so this demineralization process, desalination process. Demineralization process is ion exchange process. It is a wonderful technique to remove, I mean, especially the ions. That technique it can useful for the demineralization process, that is the ion exchange process. That process normally useful to the boiler water treatment. If demineralized water, we are using when we are using the boiler treatment, I mean industrially side, there is nothing happened in the boiler. I mean, the sludge and scale we have to avoid. When we are going to avoid. So that process is very useful. Even though some of the moderate demineralization membranes, I mean ionic changes when we are using, so that membranes also very useful for the little bit contaminated, I mean 10, 15 ppm contaminated, 30 ppm level of water. It is very good, wonderful water to having. So that is another process is a reverse osmosis method, is a wonderful technique, especially for brackish water treatment and salt water, I mean seawater treatment. So when we are going to purify the seawater and the brackish water, so this, especially this desalination process, I mean reverse osmosis technique, is a wonderful technique. In the ion exchange process, we are using some of the copolymers, divinyl benzene copolymers we are using here. So some semi-permeable membrane we are preparing. We are applying some semi-permeable membrane in reverse osmosis method. That semi-permeable membrane, it is a organic, I mean natural available membranes also available, and synthetic membranes is also there. Polyacrylate and the polyamide copolymers we are using as a synthetic semi-permeable membrane. Some of the technology people, they are preparing synthetic semi-permeable membranes, that very wonderful membrane having the capability to exchange a particular specific ion through that membrane. And here the geolite process is a wonderful technique. It is just like it's a natural process. Geolite process is the natural process comparatively remaining other techniques. Geolite means there is a two type of it is a one type of silica. Geolite means is a one type of silicates. Is a three-dimensional silicates. Geolites is a three-dimensional silicates. Normally hydrated sodium, aluminum, I mean rare earth elements and alkaline elements, alkaline rare earth elements, contaminated silicates is called as a geolites. So the geolites chemical formula is sodium oxide, Al2O3, and X number of silica and Y number of water molecule is present. This is the basic chemical formula of geolites. Geolites, if you X silica and Y, that means water molecule, if it changes, the geolites nomenclature also it can change. Geolites is capable to exchange of ions with sodium ions. It have the sodium ions. The sodium ions it can exchange to the other cation. That is the advantage of natural geolites. So that especially these geolites is capable to exchange of hardness producing cations and anions. It can easily to remove the hardness causing cations and anions through this geolite process. So that's why this is called as a geolite permute process. Permute is the one type of synthetic geolite. So that's why we are called as the geolite permute process. Permute is a one type of synthetic geolite. Geolite can be written as Na2Ze. Ze means it is a geolite. Ze means we are represented geolite. Geolite is having sodium ions. The two sodium ions, especially it is replaced by, there is a number of sodium ions present in the crystalline structure of geolite. These sodium ions is replaced by calcium and magnesium ions in this geolite process. And the structure of geolite, if you see the structure of geolite, please.
So time up, sir, attendance. Hello.
Vinay, tell me.
Sir, time అయిపోయింది sir. ఇంకా 1 minute ఉంది.
1 minute, right? It's okay, no problem. We will continue to Monday.
Sir, attendance.
Yeah. Please respond your attendance. Number D1. D1 is absent. D1 is audible.
Sir, her mic is not working. She's present. You can see her video.
Okay, it's fine. Okay, then it's fine. D2,
Present, sir.
D3, please respond
Present,
with
sir.
attendance. D4,
Sir, he is present. He has some network problem.
okay. D5,
Present, sir.
D6,
Present, sir.
D7,
Present, sir.
D8,
Present, sir.
E9,
Yes, sir.
E0,
Present, sir.
E1, E2,
Present, sir.
E3,
Present, sir.
E4, E4, okay. E5,
Present, sir.
E6,
Sir, E4 present.
that's fine. E6, E6, E7,
Present, sir.
E8,
Present.
E8,
Present, sir.
E9,
Present, sir. No problem.
F0,
If not present, sir, no problem. Messages.
there is mic problem, huh? F1,
అవును sir.
Present, sir. Not present, sir.
very good. F2, F1,
F1 present, sir.
F3,
Present.
F4,
Present, sir.
F5,
Present, sir.
F6,
Present, sir.
F7,
Present, sir. F7.
F8,
Network issue.
Present, sir.
F9, okay. G0,
Present, sir.
G1,
Present, sir.
G2,
G2 present, sir.
G3,
Micro.
Present, sir.
G4,
Present, sir.
G5,
Present, sir.
G6, G7,
G7 present, sir.
G8,
Present, sir.
G9,
Present, sir.
H0,
Present, sir.
H1,
Present, sir.
H2,
Present, sir.
H3,
Present, sir.
H4,
Present, sir.
H5,
Present, sir.
H6,
Present, sir.
H7, H7, H8,
Present, sir.
H9,
Present, sir.
J0,
Present, sir.
Present, sir.
J1,
Present, sir.
J2,
Present, sir.
J3, J4,
Sir,
Present, sir.
okay, J4, J5,
Present, sir. Present, sir.
J6,
Present, sir.
J7,
Present, sir.
J8, J9,
Present, sir.
J9 present.
K0,
Present, sir.
K1,
Present, sir.
K2,
Present, sir.
K3, K3 absent, huh?
K3 present.
Okay, K4. K4, okay, K4 absent. Okay, thank you very much.
Sir, H7 present, sir.
Okay,
Sir,
fine.
F2 present, sir.
Okay, okay.
F1 present, sir.
Yeah. It's fine. Thank you so much.
Sir, absent is.
Thank you, sir.
Sir, F not present, sir.
Sir, one still absent is.
I will send the members.